challenges that you clearly have before diving deep into the business problem. So so this Titanic is, yes, it is interesting, but I'm pretty sure that the real world examples are even more interesting than this. So I specifically chose this example because we can correlate with the movie story that we have seen already, and then we can go ahead, right? Yep. So yep, we have seen this. And if I'm from, so most likely this 97 and 80 are from the passenger class one, they are most likely to be men because women were given preference, that we saw it already. And the passenger class does have some sort of an impact, right? So that's what we have seen. And again, the survived one, the 119 from the passenger class 3 are most likely to be women because we have seen it in the data, and the charts say the same. Charts say that only 81 women did not survive the crash. So you see here, I'm switching back and forth because that's how you interpret the data. You take the graphs, put them side by side, and then you draw the inferences and you make your statements, right? So it's a good practice for you guys. Okay, so now we have seen the gender and the passenger class. Now we'll go ahead for the age density, right? So age density is what's the split of the number of people, say 800 people, where they are most likely to lie in. So most likely they were in the age group from 20 till say 50. This covers almost 80% of the 80% of the you know the population in Titanic, right? So this is again, age density is to see whether age does have an impact on our the data science model or not. Correct. So that's the reason we're just putting in the we're just setting up the stage for designing a model. So nothing fancy. Like, these are just we are just taking the one variable, and then we are seeing whether that has an impact on your y variable, survival rate or not. Right. We'll move ahead. So we'll see. You see this? What we are trying to see here is, um, we are trying to see the survival rate by age. Like, if you see here, the kids, 0 to 10, or like 0 to 10 or the kids, 10, 20, 20 to 30, 30 to 40, so on and so forth. Okay, so we are just trying to say that we have taken the age, and inside the age, what is the male and female ratio, who's I mean, not, sorry, not male and female, who survived and who has not survived. Okay, so now coming to the part where we create the test and the train part. So what we are trying to take here is, we are trying to take the 80% of the data, and then we are trying to study how they were distributed, right? Like, see, where in Excel sheet, yeah. So out of this 800 or 50 so passengers that we have it already, we are trying to see whether uh, whether we can form a data science model, right? So we take a sample, we build the data science model, we predict, we already have our answers in here in the survival column, and then we are trying to evaluate the model based on the survival rate, predicted survival rate versus the actual survival rate, right? So that's what we are going to do now. So I hope you guys are clear. Do we have any questions in place, or you want me to explain anything in detail? Cool. So we'll move ahead because we have quite a few algorithms in here. So here we are trying to see whether having any relationship in the name or not. So don't worry about it. So we're just predicting it. So here we did not remove the name. Okay. Get it. Okay, guys. So what I'm trying to do is like since we have messed up with the data, like the actual data, like there is a blank spaces in here. So you see here. So what I'm trying to do is like I'll I'll re-download the data in here, and then we'll go ahead from the beginning. Okay, so I have the file somewhere in the downloads. Yeah. Yep. So now it works perfectly. So the reason it did not work perfectly is sometimes. So I was like I was being careless, and I for experimental purposes I typed in the spaces wherever I had it. But ideally, whenever you have that data, it should be like a proper data. Else you are bound to see some errors that are there. So make sure that you do not mess with the actual data that you're trying to read. Like take a copy, obviously, and then work on it. So now we have this the a ratio for the uh, the sex and the passenger class and the age and then siblings and spouse. So if you see this, it looks like a flowchart. You know, I'll try to open as an image and then yeah. So if you see here, I hope you guys can see my screen. So if you see here, initially what we are trying to do is uh, we are trying to divide them by their gender. If they are male, male as in the sex is equal to male, then yes, this particular chart is for male passengers. This particular part is for female passengers. Like you cut the entire flow chart into half. I mean, this just gives you how much everything is relatable to your whatever the variables that you have. So the passenger class 3 and 2 and the age, say greater than or equal to 13 or greater than or equal to 40, and then their survival rates in the bottom. You see here the 0, 1, 0, 0, 0, 0, etc. Okay. So far whatever we have inferred, we started getting the proof. Okay, meaning so you read the flowchart like this. Are you a male or a female? If you're a male, then you have say 37% of survival, like even without being a first class passenger or a I don't know, so um, or some other third class passenger, like just being a female or a lady gives you an advantage. Okay, and if your passenger class is 3, then you have like say 22% of the survival right? But if your passenger class is like 0, uh, passenger class is 3 means like it your passenger class is exactly 3. Passenger class is 0 means it is either 1 or 2. Like both of them are clubbed together to form a single bucket. Okay. Remember again. So since we just mentioned that passenger class is a, the category, all these flow charts are being taken care by your or programming languages. So similarly, how you do it and say like in your I don't know. So in your one of your lab experiments, you're not drawing this flow chart by hand. No, that's not happening. So it is an auto-generated chart that you're looking at. Okay. So if you look in here, like if you have say if you are from passenger class 1 or 2, like you have say uh, if your age is greater than or equal to 39 and so on and so forth, and if you're a young woman, you're most likely to survive. And if you're a kid, greater than or equal to 6.5, again, you're going to survive. So this is again, right now we started getting the data points for us to consume, like meaning, so far we have made certain inferences saying that if you're a female candidate or if you're a female passenger, you're most likely to survive. So now we have the numbers to support the hypothesis. So that's how we can see it, right? So I hope I made this chart clear. So do you guys have any questions? Right. So what we are trying to see here, like a predict is nothing but like instead of a linear regression. So since we are so linear regression is for okay, I'll write it in the code. Okay. For linear regression, or in simple terms, to predict numerical variable, you use the LM function. For logistic regression, or to predict the categorical variable, you use the predict function, right? So so we have seen the LM function because we're just dealing with the numbers. We are trying to predict a number based on another number. It's just like trying to predict your M4 score based on your M3 score, right? So that's what is happening in our previous example. But in here, it's more like saying that whether it's a categorical variable, it's a class, or it's whether you have survived or not. It's not like a numerical variable anymore because we are trying to categorize everyone into different buckets. Okay. So that's the reason we used predict. And then once we predicted, we create a matrix saying that uh, what is the actual survived versus uh, what is the rate that we calculated. Okay. So when you use the predict, if we see this particular predicted one, we have taken these people as samples and we have said that whether they have survived or not based on what the passenger class, based on age, siblings and spouse, and then based on their gender. Okay, so these are the parameters that we have taken for our observation. Okay, and we said the predict. Uh, Predict as in it's as simple as that, because we have seen in the correlation chart that somehow these variables are interconnected with each other. So in the bar graphs we have seen, in the variable correlation chart we have seen that the siblings and spouse and everything is connected. The only thing which was not connected is the passenger ID, because that is where we had no relation at all, literally zero relation. So yeah, now once you predict that whether passenger 720 is 0, right? Passenger 720 is 0 means passenger 720 has not survived. So that's what it's trying to say. Now, for our understanding purposes, like we'll just check it manually. Okay. Hopefully, I don't change anything in here. Yep. Here we go. 720. So he has actually not survived. If you see the zero, this is the actual data. Okay. So this Excel sheet is the actual data, and this whatever we have it in the R Studio environment, this is the predicted data. So you see that's the reason I named it as predicted. So if you see the predicted matrix or a predicted data frame, we just only have two levels, whether they have survived or not, and their passenger ID. 720 is their passenger ID. So what we are saying is, uh, he has actually did not survive the crash. Why? Because he is in two highly risky buckets. He is in class 3. He is a male candidate. So you see this. So this is his class 3 and he is a male candidate. So that's the reason he did not survive. So we can say that in even in reality this is happening. So we are saying that he has not survived, and even the model predicts it correctly. So similarly, we have to do it for the other exercises, like I mean for other passengers. So doing that would be, uh, really a time consuming process. So that's the reason we are finding out the accuracy by tabling it, like who has survived in the test data set and who has survived in the predicted data set, and then we are trying to find out how many we have forecasted, or how many we have designed the model correctly, right? So when we print accuracy, it says 0.81. So 0.81 converts into 81 percentage, meaning so with 81% accuracy, we can clearly say that the passenger has died or not based on the parameters, their gender, their passenger class, their age, and their siblings and spouse, right? So you get the idea, right? Like, so this is the real world example in the uh, in how you design the data science model. So when I say data science, I don't do anything fancy. So all I do is I care for this particular 100th line. So actual model is actually only one line. It's nothing more than that. But to reach the line 100, I have to write like 99 lines of code. I have to clean the data. I have to make sure that I choose the right variables. I have to make sure that I have a right set of categorical variables, and I have to make sure that whatever I'm doing is correct or not. Say, if I say, if instead of the passenger class, if I go ahead with, oh my god, I close the data. But again, the idea is instead of the class, if we go with the cabin, my results would be significantly different. Why? Because we do not have the data at all, right? So we do not have the data. So that's the reason we removed upfront, and then we cleansed the data to some extent, and then we did the actual modeling part. And after that, it is again a mix or match. Like once you have the predicted data, you mix and match between the actual data and your predicted data, and you calculate the accuracy. So this is how you calculate your accuracy in either linear or logistic regression. So we'll go for the fine tuning later. So for now, I will take a pause in here. Like, do you guys have any questions, any concerns, comments? How much time do we have left? Like, yeah, still we have like 30, 45 minutes left. So we'll cover most of the things. Fine. Okay. So now, is this accuracy enough for us? This is the typical business question. So, what is the level of accuracy that we wanted to achieve? So, for us, since we deal with the financial data, it has to be always above 95%. So say I'm having the 100 data points. Not necessarily I need to have the 100 data points forecasted correctly. I need to have 95% of the data points I need to forecast it correctly, and then the remaining 5% are okay. So anyway, they don't deviate much, or they should then we don't worry about it. So this is in case of the financial data. Like, but in here, we have to constantly see whether we can improve, or whether we can adapt any other model in here, because 81% is, yes, it's not bad, but it's not very good either. What if some other model, or some other, we are going for logistic regression, right? Like, we have done the simple logistic regression, not any other algorithms. What if we try another different algorithm and it gives us the better results than this?